Alright, so this is going to be a video about the difference between direct and inverse variation. Direct variation occurs when you have an equation where it's y is equal to kx. And this k right here is just a constant. And you can solve for this k by dividing both sides by x, and you'll have k is equal to y over x. Okay? The inverse variation is different than the direct because instead now it's k divided by x to solve for y. Here it's y equals k times x. Here it's k over x. And to solve for k, you'd have to multiply both sides by x, and you have k is equal to x times y. Now, what does that look like with problems? Well, here's an example. All right, so for direct, what a problem might look like is if it says x and y are two variables that are in direct variation with each other. So let's just say that y is equal to 2 and x is equal to 1. Okay, well, if y is equal to 2 and x equals to 1 under this direct variation, then you should be able to solve for k. Right here, k is equal to y over x. Y over x is 2 over 1, which is equal to 2. Okay, well, that's not much of a problem, but a problem might look like where it says, okay, if 2 and 1 are directly proportional to each other, and y is also equal to 4, for another example, what would x be equal to? Okay, well, to solve this, because these are both in direct variation with each other, they have the same k. So that means the k is equal to 2 in this case right here as well. So the k's match. So if the k's match, we should be able to solve for x here. So let's write our formula out. Y is equal to k times x. Okay, we're going to put 4 in for y, 2 in for k, and we're going to solve for x. So you divide both sides by 2, you end up with x is equal to 2. So we'd end up able to solve for x. So that's kind of how a direct variation problem looks. Let's look at an example for inverse variation. Okay, let's instead say that y is equal to 3 and x is equal to 1. So these two numbers are inverse variation. I'm telling you that for the problem. They're in inverse variation with each other. You should be able to solve for k pretty easily because it's just x times y, so you end up having 3. Okay, so let's say y is now equal to 6. So our y doubled. What is going to happen to our x? Well, if you see over here, the y doubled here, and then the x right here doubled as well. But that's because it's direct variation. They multiply by each other. So if this multiplies by 2, this should also multiply by 2. Inverse variation is a little bit different. Let's see how it's different. So the k's are the same, just like the direct variation. So these numbers are in direct variation with these numbers are in direct or inverse variation with each other. So with these, because it's in the same inverse variation. All right, so we need to solve for x here. Let's put our equation in here. Y is equal to k over x. Okay, we have y, which is equal to 6. K is equal to 3, and we're solving for x in this case. Okay, we're going to multiply both sides by x, and we're going to get 6x is equal to 3. Divide both sides by 6, you end up with x is equal to 3/6, which is equal to 1/2. Okay, so it went from 3 and it doubled to 6. The 1 ended up going divided by 2 to get 1/2. Okay, so that's inverse variation and showing how it differs from direct variation. Now I'm going to show you some graphs that really kind of knock home the point between direct variation and inverse variation. So here we go. All right, so I'm going to use Desmos here to show you the difference between direct and inverse variation graphs. So for the first one, we're going to do direct variation. So I'm going to write y equals k times x. And then I'm going to add the slider k like so, and then you can see k is equal to 1. Now, the graph that ensues from this that's created is a linear graph that has a y-intercept at 0. So I'm going to hit play here, and it shows you exactly what kind of k's you can have for direct variation. The one important difference here that it's going to show right here, if it's 0, so if I put k equal to 0 right here, this technically would be considered not to be direct variation. So k has to be not equal to 0 for direct variation. But other than that, this is what a direct variation graph is going to look like. Okay, now we're going to use this to compare it to y equals k over x, which is the inverse variation. So I'm going to turn this one off for now. I'm going to add another one that's going to say y equals k divided by x, and you end up with a graph like this. Okay, if I can do the same thing with the k, where if I change this value, as you can see, it looks dramatically different than the y equals k over x. This one kind of forms these curved lines that are on either side. And as you can see, if I put this to 0 as well, you end up just having this straight horizontal line on the x-axis. This would not be considered inverse variation, so k would not be able to be equal to 0 for this as well. So again, you have this set of curved lines here for the inverse variation versus the y equals kx for the direct variation. You end up having just a straight line that looks like this. So here's both of the graphs graphed together with the k's moving throughout. I can speed this up a little bit. So hopefully the graph helps explain the difference between direct and inverse variation as well. So if you have any questions on any of the inverse or direct variation, let me know.